Okay, good morning, everyone. Can we start the
Good
class now?
morning, sir.
Slide is visible, no? Okay.
Yes, sir.
Okay, so yesterday we talked about the anatomical part of the urinary bladder, ureters, and what is that? Posterior urethra, no? Okay, and regarding the nerve supply also we have already discussed. But all these things will be discussed in more detail, I think, in anatomy class. Okay, so today we'll talk about the mechanism of micturation or mechanism of urination, you can say. Okay, so micturation has two stages or phases. Number one is the resting or filling phase. Okay, so during resting or filling phase, urine is being transported from kidneys to bladder via the ureter. So we all know urine is formed by the nephrons, okay, and that is flowing towards the papilla, calyces, all these things, ureters, and then to the urinary bladder. Okay, so the second stage of the micturation is the voiding phase. It is simply expulsion of urine from the bladder. Okay, expulsion of urine from the bladder. So when we talk about the micturation, it also includes the, we can say, the filling phase of the, filling of urine into the urinary bladder. Okay, and when urinary bladder is filled to some extent, okay, there will be a desire to void or to excrete the urine. Okay, and that will include then the second phase will follow, that is the voiding phase on the expulsion of the urine from the bladder. Okay, so let us see in brief, okay, how filling of bladder takes place. So we all know that urine, they are collecting from the collecting ducts. Okay, from the collecting ducts, you know that it will flow into the renal calyces. First here we can see first the minor calyces, okay, and then the major calyces. Okay, from the major calyces itself, this filling of the calyces itself, it is stretching the wall of the calyces. That means when fluid is flowing through these calyces, ultimately there will be some effects on the wall of the calyces. That means it will stretch the wall of the calyces. Okay, so this stretching of the wall of the calyces, it will increase the inherent pacemaker activity. That means what we have already discussed earlier. That is action potential, or first it will be the pacemaker activity. That means there will be increase in the the potential. Okay, the depolarization will be there. Okay, and this pacemaker activity or action potential, we can say it will spread to the renal pelvis and ureters. Okay, so this is the renal pelvis or the upper part of the ureter, and that stretching of the wall, it will also lead to increased pacemaker activity into the ureters. Okay, ureters will also be activated, and when this activity or that action potential, or we can say increased pacemaker activity, is reaching the ureters, it will initiate peristaltic contraction. That means it will lead to the contraction of the smooth muscle of the ureter. Okay, smooth muscle of the ureter, and that contraction will be it is pericellic contraction. It is a wave-like contraction. Okay, so contraction of smooth muscle. Okay, it will be wave-like, and it will move throughout the, here we can say, wall of the ureter, and it will reach the urinary bladder. Okay, so this pericellic contraction, it is because of the contraction of the smooth muscle of the ureter. And this peristaltic wave in ureter increases pressure within the ureter. So it is clear that when there is contraction, okay, or in the wall of the ureters, okay, pressure will be increased ultimately, and region passing through the bladder walls will open. When the peristaltic pressure is reaching here, okay, this increased pressure will also lead to increased flow of urine towards the bladder. Okay, and region passing through the bladder wall opens. Okay, so here the ureter, that what we say urethral opening, it will be open. Okay, allows urine to flow to the bladder. So ultimately, urine will flow into the bladder. Okay, and during this feeding phase, as you know, the urinary bladder is relaxed. Okay, that means the detrusor muscle that what we have discussed yesterday, muscles of the urinary bladder, they will relax. Okay, they will relax so that it can accommodate the urine which is coming from the kidney through the urethra. Okay, and then after sometimes this urine, you know that the detrusor muscle relax and it will be filled with the urine. Okay, and this filling of the bladder, okay, it will what to say it when there is increase in the volume of the urine. Okay, it means that the bladder, it has to what to say expand, or it will distend to accommodate more urine. Okay, so this is how filling of the bladder takes place in short. Okay, so rate of contraction, Pericellic wave. Okay, it is around 0.5 to 100 times per minute. Okay, so the Pericellic wave in the ureter, it is around, the rate is around 0.5 to 10 times per minute. Okay, that means one Pericellic wave will be there, okay, which will pass through the ureters. Okay, and after that is finished, another wave will come again. Okay, here on the right side also. Okay, that will be repeated again and again. And within 1 minute, the rate of contraction may be, Pericellic wave may be 0.5 to 10 times. Okay. So in adult men, intravesicular pressure of empty bladder. Okay, intravesicular pressure here in this case we can say the pressure inside the urinary bladder. Okay, when the urinary bladder is empty, the pressure is 0 centimeter of water. Okay, and suppose the bladder is filled with 30 to 50 ml of urine, the pressure will be 5 centimeter of water. Okay, and when the bladder is filled with 200 to 300 ml of urine, the pressure rise will be minimum. That means the rate of the rise of the pressure will be decreased. So here, the first diagram you just see, okay, and this one, this red line, what to say, graph, you just see. You see that here initially the rate, the increase in the rate of the what to say pressure, it has increased a lot. Okay, around 300. Okay, the rate of increase in the pressure, it is minimum. It is said that. Okay, but above 300 ml of urine, if it is there in the urinary bladder, so the rate of increase in the pressure, it will rise again. Okay, so let's see in adult men the sensation of what to say bladder feeling. Okay, first sensation of bladder feeling will be felt when the bladder is filled with around 100 to 150 ml. Okay, and first desire to void or urinate, it will be around 150 to 250 ml of urine in the bladder. Okay, uncomfortable, aware of full bladder. When you are feeling uncomfortable and you are aware that your bladder is full, so the volume of urine in the bladder is around, at this condition, 350 to 400 ml. Okay, so initiation of reflex action occurred around at this area. Okay, reflex action will start, initiation of reflex action will start when the bladder is filled with 300 to 400 ml of urine. Okay, and pain and loss of control. Okay, so you don't have a chance to urinate, okay, or to void your urine. Okay, so you will feel pain and loss of, you may not control. You might not be able to control now. Okay, that you cannot stop that urination. Okay, so when the bladder is filled with it at this condition around 700 ml of urine. So yesterday also I told you that because of that somatic nerve. Okay, you can control or you can stop your urine. You can postpone it, but that may not be possible if the bladder is having too much of, let's say, urine. Okay, let's say in adult human being, around when it is reaching around 700 ml. Okay, then there will be pain and there will be loss of control. That means the urine may come out automatically. Okay, involuntarily. Okay, so what is micturation reflex? Okay, this is the reflex. As bladder fills, many superimposed micturation contractions begin to appear. Okay, so in the bladder you can see these are the micturation contractions, this dash line. Okay, as shown by the dash spikes. Okay, so these are micturation contractions. So as you can see, as the volume or the pressure of the urinary bladder has increased, keeps on increasing. Okay, the micturation contraction also, it keeps on increasing. Okay, so you can see that it will go first contraction and it will reach peak and it will come back. Okay, going up, coming down, going up, coming down. But every time when there is a new spike or micturation contraction, the peak will keep on increasing. Okay, that means more and more contraction is there. Okay, the strength of contraction is higher. Okay, keeps on increasing. Okay, micturation contractions are the results of the stretch reflex. Okay, stretch, you all know that whenever there is stretching of something, okay, this reflex will be produced. Okay, this reflex is initiated by sensory stretch receptors in the bladder wall. I told you that there are some nerve endings in the bladder wall which are sensory in nature. That means they can detect change in the environment. Okay, that means stretch receptor means they are sensitive to stretching of the wall of the bladder. Okay, especially by the receptors in the posterior urethra when this area begins to fill with urine at the higher bladder pressure. That means this area. Okay, this is the posterior urethra. Okay, so when this is filled, okay, it is very sensitive. Okay, so this is all because of what to say, filling of the bladder with the urine. Okay, so posterior urethra, they are very sensitive to this stretching. Okay, so large number of stress receptor, they are present in the wall of the posterior urethra. Okay, so let's see first what is the effect of sympathetic stimulation. Yesterday we talked about the sympathetic, parasympathetic, and somatic nerve fibers, okay, which supply the bladder and the urethra. Okay, we have already discussed. So what happens when there is stimulation of the sympathetic nervous system? Okay, the first effect is that when you stimulate sympathetic nervous system, the first effect is it will cause bladder relaxation. That means urinary bladder will be relaxed. That means when there is stimulation of sympathetic nervous system, it is important that the bladder relax so that feeling phase can take place. Okay, so stretching of bladder wall, okay, lead to stimulation of bladder sensory stretch receptors and sensory signals through hypogastric nerves. Okay, so here there is the stretching of the wall of sympathetic stretching of the urinary bladder. Okay, here we can say what it will do is that, as I told you, this the wall of the urinary bladder, they are having the nerve endings. These are the sensory receptors or sensory nerve endings, we can say. So because of that, this, you see, there will be descending of impulse towards the central nervous system, and it will reach the spinal cord. Okay, okay. So this signal is true, as you know, it is the hypogastric nerves to the spinal cord. SC means spinal cord. Okay, this because of stretching of the wall of the urinary bladder, sensory impulse is sent to the spinal cord. Okay, through the hypogastric nerve. Okay, and signal reaches the spinal cord here. It will reach the spinal cord, and this will be processed, this signal or this sensory impulse will be processed in the spinal cord. And what will happen is that it will send back, what to say, motor signals, okay, and motor impulse towards the urinary bladder again. Okay, so here it is coming back. But before reaching the urinary bladder, there is a ganglion. Okay, here it will synapse with another neuron. Okay, so this is known as postsynaptic neuron, and this is known as presynaptic neuron in this case. Okay, so now it will synapse here with the another neuron. Okay, motor signals via sympathetic preganglionic axons in the hypogastric nerve. Okay, and synapse with sympathetic postganglionic axons in the hypogastric nerve already. All sympathetic postganglionic axons in the hypogastric nerve release what is known as norepinephrine, NA. Okay, and can stimulate then beta-2 adrenergic receptors in the bladder smooth muscle. Okay, I'll repeat once again. And what this will cause, it will cause a relaxation of the muscle. Okay, so here sensory nerve fibers, it is going towards the spinal cord, and this sensory impulse is now processed in the spinal cord, and after that spinal cord will send back a motor impulse, okay, through motor neuron. Okay, this is hypogastric nerve. Here in the ganglion, it will synapse first with another neuron, and this postsynaptic neuron then send the signal towards the urinary bladder in the urinary bladder wall. Okay, this will synapse with beta-2, okay, adrenergic receptors. Okay, and what will happen is that here it will release the neurotransmitter known as norepinephrine, noradrenaline, NA. Okay, and this NA will bind to beta-2, what to say, adrenergic receptors, and this will cause conformational change, and it will lead to relaxation of the bladder. Okay, so the first effect of sympathetic stimulation is relaxation of the bladder. As I told you, this is important for the, what to say, feeling of the urinary bladder with urine. Okay, so now another possible effect of sympathetic stimulation is contraction of the urethra or contraction of the internal urethral sphincter. Okay, again, let's say the first point is that when there is stretching of the wall, bladder wall. Okay, again, the same thing will happen, stimulation of the bladder sensory stretch receptors, and then this sensory signal, again, it will go to the, let's say, spinal cord through the hypogastric nerve. Okay, and what will happen is that signal reaches the spinal cord, again, it will be processed in the spinal cord, and spinal cord will send back what is known as, let's say in this example, okay, so this, you just say this one, this neuron. Okay, after synapse in the ganglion, the post ganglionic neuron, it will send signal back to the, again, urinary bladder, and here it is, the area is different now. Okay, here that means it is through hypogastric nerve. Again here, noradrenaline will be released again. Okay, just like the previous one, but the receptors here, it is different. Okay, it is alpha-1 adrenergic receptors. Okay, previously it was beta-2. Okay, here it is alpha-1 adrenergic receptor is present. So when the release noradrenaline bind to these receptors, okay, it will lead to what? Urethral smooth muscle contraction or internal sphincter. So we know that here the internal sphincter, urethral sphincter that we have already discussed yesterday, it is there. Okay, instead of relaxing it here, now it is causing the contraction. The first action of sympathetic stimulation was relaxation of the bladder. Okay, the second effect of sympathetic stimulation is that it can also contract the, what to say, urethral smooth muscle, or we can say that internal urethral sphincter. Okay, so it is opposite. Okay, relaxation of the bladder, but contraction of the urethral muscle. Okay, Now the third, what about the parasympathetic stimulation? Okay, when there is parasympathetic stimulation is there, the effect will be bladder contraction. Okay, so let's see again. So suppose there is stretching of the bladder wall, stimulation of bladder sensory stretch receptors. So it is clear that here sensory receptors will be stimulated again. Okay, and sensory signals through the pelvic nerves. So this is through the
Sir, you are
earlier it was hypogastric. Hello? Am I audible? Okay.
Sir, your voice is breaking.
Breaking. Okay, maybe because of I think there is some problem in the internet here, though it is quite good. Okay. But you just inform me now when there is problem. Okay. So this is the what to say, the general outlines means the mechanism is similar only. But there is a difference in the what to say, the what to say what is the nerve, what is the receptors. Okay, there is some difference. Okay, so in case of parasympathetic stimulation, again, bladder wall stretching is there. Again, that will ultimately stimulate the sensory nerve endings or sensory receptors also we can say. Okay, that means it will send again impulse towards the spinal cord. Okay, so it reaches the, so again inside the spinal cord, these sensory signals will be processed. Okay, and the spinal cord will send out again, let's say, all this motor impulse. Okay, this is parasympathetic predominantly actions in the pelvic nerve. So as you know, this is the pelvic nerve to the pelvic nerve, and then synapse with the parasympathetic postganglionic actions in the nerve. Okay, and here there will be a release of acetylcholine, ACH. Okay, and then what acetylcholine will do is that it will bind to M2 muscarinic receptors in the bladder smooth muscle. So here you can see M2 receptors. Okay, here the neurotransmitter involved is the acetylcholine. Okay, so in case of, you know, the sympathetic stimulation, it was noradrenaline, but sympathetic nerve fibers, it stimulate two types of receptors. Okay, beta 2 and alpha 1, and the effect is opposite. One, it causes relaxation. Another one, it causes contraction of the urethral sphincter. Okay, urethral, we can say internal sphincter. Okay, then what it will do is that here is that it will cause contraction of the bladder. Okay, so it is very, very simple. That means sensory impulse, it will go to the spinal cord and it will send out what motor impulse. Okay, and the effect is different. It may cause relaxation, it may cause contraction. Okay, so what about the last one? Okay, yesterday also we talk about somatic stimulation. Somatic is, as you know, it is voluntary control. Okay, let's see this one. So let's say there is stretching of the posterior urethra. Let's say this portion is the posterior urethra. Okay, this is the posterior urethra. Stretching is there because the urinary bladder is full now, or we can say it is filled with high pressure, and the posterior urethra will also contain some amount of urine. Okay, so that will cause, it will cause stretching of the posterior urethra. Okay, then external urethral sphincter sensory stretch receptors, they are stimulated. Here also sensory stretch receptors which are present here, they will be stimulated. Just like the previous one, what they will do is that here they will send out sensory signal to the spinal cord. Okay, and this is through pudendal nerves. Okay, and signal reaches the spinal cord, and it will be processed here in the spinal cord, and again it will come back as a motor impulse. Okay, through the pudendal nerve. Here you can see, and then motor nerve reaches this. It will release what is known as acetylcholine. Okay, neurotransmitter acetylcholine, and acetylcholine, what it will do is that it will stimulate alpha nicotinic cholinergic receptors in the external sphincter. Here, that is not written here. Okay, here the receptor present is alpha 1 nicotinic cholinergic receptors. Okay, So acetylcholine will stimulate the receptors, and what will happen is that it will relax external urethral sphincter, so that urine can be expelled. Okay, that means when this external urethral sphincter contract, it means the lumen is occluded. Okay, the lumen is occluded, but then you decide to urinate. Okay, by your own will, you can relax the external urethral sphincter. Okay, that means this will be sent, this sensory signal will be sent to the spinal cord, and it will come back as the motor impulse will come back like this, and here it will in the synapse here, it will release the acetylcholine, and acetylcholine will bind to the alpha-1 nicotinic cholinergic receptors that will cause relaxation of this external urethral sphincter, so that the lumen will be open. Okay, urethral lumen will be open, and then urine can be expelled. Okay, so steps in the micturation. Let's see, bladder only partially filled. So initially the volume of the urine will be less. Okay, that means bladder has started filling itself with the urine, and we can see initially some weak micturation contraction when the volume is low. Okay, but as you can see from the diagram, so here it will reach a peak and then it will relax. Okay, like that. This is the contraction, and then pressure falls back to the baseline. As you can see, pressure falls back to the baseline. Once a micturation reflex begins, it is self-regenerative. That is, initial contraction of the bladder activates the stretch receptors, to cause a greater increase in sensory impulse from bladder and posterior urethra. Okay, there will be increase in micturation contraction. Okay, which causes a further increase in reflex contraction of the bladder. So the meaning of this one is that as the filling of the urinary bladder keeps on increasing. Okay, so micturation reflex will the contraction of, let's say, micturation contraction will keep on increasing in strength. As bladder fills will continue, micturation reflex cells become more frequent and stronger, greater contraction of the detrusal muscle. Okay, so the muscle of the urinary bladder the contraction will keeps on increasing, intensity will be more and more, further increase in reflex contraction of the bladder. Okay, cycle repeated again and again until bladder reaches a strong degree of contraction. Okay, once a micturation reflex becomes powerful enough, it causes another reflex which passes through the pudendal nerves to the external sphincter to inhibit it. Okay, so because of filling of the urinary bladder, okay, micturation reflex, it is increasing. Okay, it keeps on increasing, and then the detrusor muscle contraction will also it will increase. Okay, its contraction. Now, when this micturation reflex become powerful enough, it causes another reflex. That means that conscious desire to urinate, or we can say it is through the pudendal nerves, the somatic nerve I've already told you, to the external sphincter to inhibit it. Okay, if this inhibition is more potent in the brain, then the voluntary constriction signal to the external sphincter urination will occur. It means if the volume is too much, okay, so you cannot control it. Okay, so because that means that if this inhibition is more potent in the brain, then voluntary constriction signals to the external sphincter urination will occur. That means you can control your urination. It will simply come out. Okay, but the second condition is that if not, urination will not occur until the bladder fills still further and the micturation becomes more powerful. Okay, that means you still have you still have it can still control. Okay, it can still postpone the urination if the volume in the urinary bladder is not high enough. Okay, but again, after some time, there will be more feeling of urine in the urinary bladder, and that will increase what to say the pressure. Okay, and in that condition, the first condition will follow. Okay. So next is the uremia. So uremia is a pathological condition. Okay, but it is there in your syllabus. Okay, so let us just discuss in brief. So what is the meaning of uremia? Elevated blood concentration of urea, creatinine, and other nitrogenous end products of amino acid and protein metabolism. Okay, when you say that, what is uremia? It is increase in the concentration of urea, creatinine, or other nitrogenous products of amino acid in the blood. Okay, so uremic illness is due largely to accumulation of organic waste products that are normally cleared by the kidney. Okay, so this condition is because of accumulation of, as you can see, accumulation of organic waste products. What is azothimian? This is a less severe condition of, we can say, uremia with high levels of urea. Okay, so there is increase in the urea. Okay, but it is not that severe. So when it is not that severe, it can be referred to as azothymia instead of uremia. Okay, abnormality can be measured chemically, not yet so severe as to produce symptoms. So in case of azothymia, the symptoms may not be manifested. Okay, so uremic syndrome, terminal clinical manifestation of kidney failure. So when we say uremic syndrome, it is a very severe condition of the uremia, and it reflects results from inadequate excretory, regulatory, and endocrine function of the kidneys. Both uremia and uremic syndrome have been used interchangeably. Okay, so we can use uremic syndrome or uremia, but specifically when we say that uremic syndrome, it is an advanced stage. Okay, so what are the causes of uremia? High blood pressure, polycystic kidney disease. That means there are some cysts present in the kidney, which is genetic in nature. Number 3 is diabetes, maybe type 1 or type 2. Okay, or inflammation of the glomeruli, inflammation of renal tubules and the structure around them, and large prostate, or some types of cancer. So these are the causes of the uremia. Signs and symptoms. Number 1, progressive weakness and easy person will be easily fatigued. Number 2, loss of appetite due to nausea and vomiting, muscle atrophy, tremors, abnormal mental function, frequent shallow respiration, metabolic acidosis. Okay, so these are the signs and symptoms. What are the treatments? Dialysis is the main treatment option for uremia. So we all know dialysis. What is dialysis is? It is the removal of waste, extra fluids, and toxin from the bloodstream. Okay, which is done by an instrument. Okay, or we can say artificially it is done. So under normal condition, the kidney will do this dialysis. Okay, our natural organ, excretory organ, kidneys will do dialysis. But when the kidney is having some problem, it cannot do clearing of all those waste material properly. So an instrument can be used. Okay, that is, the process is known as dialysis. It means it will remove waste material and even the excess material. Okay.
Sir, you are not audible. Sir, you are not audible. तुम चुप हो जाओ.
हेमंत क्लास खत्म हो गई क्या? ठीक है, मैं तो अभी अभी घुसा।